Hello guys, welcome to my YouTube channel. I would like to introduce you to the basics of algebra. The power to deal with algebraic expressions is a substantial base for a math course. I have some pretty good examples here with me right now, and we'll tackle all of them today. Before we tackle all of this, we would like to know what is an algebra. An algebra is simply or basically the study of variables and the rules for manipulating these variables. So here on the first question, we have we write number 1. We have 5p times 2q. Okay, in algebraic expressions, the multiplication sign is usually left out. So what you see here as 5p, let me say 5p here, is actually 5 times p. And 2q is actually 2 times q. So we can write this expression as 5p, 5 times p, sorry, times 2 times q. Here we have a string of multiplication signs and letters and numbers, which are coefficients. And when we see an expression this way, the multiplication is usually achieved in any order. So we can write this as is equal to 5 times 2 times p times q. And 5 times 2 is 10. This one is 10. And p times q. And as I have said earlier, in algebraic expressions, the multiplication sign is always or usually left out. So here our result will be 10pq. And we're done. So this was it for number 1. For number 2, we have 4a times 2b. So we'll take it as 2, 4a times 2b. So this is equal to 4 times a times 2 times b. And we bring like terms together. So we have 4 times 2 times a times b. This is equal to 4 times 2 is 8. So we have times a and times b. And as I have said earlier, multiplication sign can be left out. So we have 8ab. And this is our simplification. So number 3, we have 7a times 9b. 7a times 9b. So here we have a string of letters and numbers. So and the multiplication can be done in any order. So rather than for me to write the multiplication sign over and over, I can simply multiply it this way. I have 7a times 9b. So 7 times 9 is 63. So I have 63 times a. So I have a times b. I have b. This is my simplification. Simple. And I have number 4. 2pq. Here it is. 2pq times 5pr. Number 4. 2pq times 5pr. This equals, I have 2 times 5, which is 10, times p. I have 1p here. I have another p here, which is p. I have q, and I have r. But here we notice that we have 2 p's. And in algebraic expressions, when we different with variables, if you have p and p, which can be written as p times p, we see that we are multiplying the same quantity 2 times. So this one can be written as p squared. The same goes for p times p times p, which equals to p cubed. So this is actually the number of times in which we multiply the power, represent the number of times in which we multiply a variable. So I can write this one, p times p, as p squared. So I have 10p squared I have Q, and I have R. And this is my answer. I cannot further multiply. I cannot further evaluate this. So this is it. And the next, we'll deal with number 5. Sorry. We'll deal with the division of algebraic expressions. So it's 25x squared. So we have 25x squared. Number 5. 25x squared divided by 15x. Divided by 15x. So this equals 25. I have x squared, which is x 2 times. So x times x divided by 15x. So I have x in a denominator and x in a numerator. So x at denominator can cancel out the x at the numerator. So I'm left with 25x divided by 15. But I noticed that 25 and 15 have something in common. They have both they are both multiples of 5. That is, I can write 25 as 5 times 5 times x. So 25 is 5 times 5 over 15 is 5 times 3. So I have 5 times 3 here. So 5 cancel out 5. So I'm left with 5x divided by 3. This can no longer be simplified. So this is my end result. Number 6, I have 22ab divided by 11b. So number 6, 22ab divided by 11b. So we see that b and b, there's b at the denominator and b at the numerator. So I can cancel out b and b. I have 22. 22 is a multiple of 11. That is, 22 is 2 times 11. So this is 22 times a. Just write times a, which gives this divided by 11. So 11 at its denominator, cancel out 11. So I'm left with 2 times a, which is 2a. I have number 7, 18ax squared divided by 3x. Sorry, number 7, 18ax squared divided by 3x. 3x. Okay, this one equals to 18 divided by 3 is 6. So I can cancel 3, cancel out 18 to give 6. So I have 6 at the numerator. I have a, and I have x squared divided by x. So I know that x is x times x is x 2 times. So x at the denominator can cancel out 1x here. So this cancel out 1. So it remains x. So at the numerator, I have 6ax divided by 1, which is equal to 6ax. And I have one last one, which is 72ab squared. Number 8. 72ab squared divided by 40. A, what was it again? A squared b, yeah. A squared b. This one is pretty complex, but it's no big deal. It's just as easy as the other ones. So this is equal to, we have 72 a b times b, b squared is b times b, divided by 40 a squared. A squared is a times a, and we have b. So 1b cancels 1b, 1a at the denominator cancel, 1b at the denominator cancel 1a. So I'm left with 72b at the numerator divided by 40a at its denominator. But I see 72 and 40 have common factors. So I can divide both 72 and 40 by these common factors. I noticed that the highest common factor between 72 and 40 is 8. So 72 divided by 8 is 9. So I have 9b at the numerator, and 40 divided by 5 is 5. 40 divided by 8 is 5, sorry. So I have 5a at the denominator, and that's it. So we're done. Thank you guys for watching. Please comment, like, and subscribe. You can also share this video to the people you think might need help with algebra or are still new to the topic. I'll be posting videos perpetually. Thank you for watching and stay tuned.